In this next section, we're going to go through how we can do different addition and subtraction. So we're going to try to break this down first, working with something that you're probably familiar with, which is going to be working with a nutritional label. So the thing you have to remember the most is you're only going to be able to combine quantities that are alike. It's not going to make sense if I add two different things together. So in the case of a sandwich, it would make no sense for me to add the number of calories plus the number of grams of fiber. They're two different things. So the hardest part that a lot of students struggle with in math is when we throw in variables and things like that. But this is the idea you want to keep in the back of your mind. Are these two things identical to each other? Because if so, then I can combine them. If they're not, I can't do anything with it, okay? So we're going to start by making a sandwich that's going to consist of 2 pieces of bread, 1 serving of turkey, and 2 slices of cheese. And so we've got all the different nutritional labels here, and what I want to do is figure out a couple different things. The first being, what is the total number of calories for this sandwich? So if we look at our nutritional label, for the bread, each serving is going to be 66 calories. For the turkey, it's going to be 34 calories. And for the cheese, it's going to be 60. So although it doesn't say it on the wheat bread, 1 serving is 1 slice of bread. And then for the sliced turkey, 1 serving is 33 grams. And then for the cheese, 1 slice is going to be a single serving. So when I go through to find the total calories for this sandwich, I want to do the calories from the bread plus the calories from the turkey plus the calories from the cheese. So starting with the bread, each piece of bread has 66 calories. So we have 2 pieces of bread. So we add these 2 together to get the total calories from our bread. Now for the turkey, 1 serving of turkey is 34 calories, and that's the amount we're putting on our sandwich. And then we're doing 2 slices of cheese. Each slice of cheese is 60 calories. So we need to add 60 twice, okay? So if we add all of these together, it would be 286, and then the units in this case are calories. So my sandwich is going to be 286. I didn't write it after each one just because it would kind of be redundant to have to write 66 calories plus 66 calories plus 34 calories plus 60 calories plus 60 calories. But in the end, the unit is calories. Okay. Moving on, we want to find the total amount of fat that's in this particular sandwich. So again, looking at our nutritional label, for a slice of bread, there is 1 gram of fat. For turkey, 1 gram of fat. And then for each slice of cheese, there's 4 grams of fat. So adding these together, we have 1 gram for each piece of bread. Then we add 1 gram from the turkey. And then 4 grams from each slice of cheese. So adding these together gives us 11 grams. So there are 11 grams of fat in this particular sandwich. For sodium, then we move on to that part of the label. So the bread has 130 milligrams in each piece. Turkey has 335 milligrams of sodium, and each slice of cheese is 200 milligrams. So adding the 130 for each bread, the 335 for the turkey, and the 200 from each slice of cheese will give us a whopping total of 995 milligrams of sodium. Okay. So again, it makes sense to add all of these together to find these particular calorie content, fat content, sodium content. This is something you've done if you've ever tracked macros or something of that nature. But it would make no sense for me to combine these different things. So if I extend this idea to variables, we can only combine them if they're exactly the same thing. So it would make 0 sense to add the numbers from 12 milligrams of cholesterol to 130 milligrams of sodium. They're 2 separate things. 12 plus 130, sure, I can do that. It's 142. But what is that representing? Because the cholesterol and sodium aren't mixing together. They are two totally different quantities. So the same idea happens when you have a variable. If they are the same exact thing, I can go ahead and I just add the numbers in front of them together or subtract the numbers in front of them. But if they're different, I cannot do a single thing. So let's look at this example. We want to simplify if possible. So looking at example A, we have 5x plus 2x. Again, think of x just as the unit for it. I have 5 x's, I'm adding 2 more. They are the same type of thing. So all I'm going to do is add the numbers in front of them. So 5 plus 2 gives me 7. So in total, this gives me 7x, okay? The unit is unaffected. The variable is not affected. X plus x does not give me x squared. All this is doing is I'm having 5 of this object x and I'm adding 2 more of them. So in total, I have 7 x's. So all that's changing is the number in front, but not the variable itself. Same idea for this next one. I have 5 x's and now I'm going to subtract 2 of them. So what that's going to do is it's going to condense down. 5 minus 2 is 3. So this in turn leaves me with 3 x's. Okay. If you change the variable, same thing. 6u minus 11u. I want to keep track of how many u's I have. So if we do 6 minus 11, this gives me negative 5. And my unit is just u. So in total, I have negative 5 u's. Okay. For this next one, I have 4x squared and 7x. So although it's the same variable, x squared and x are different. They are not the same quantity. So in this case, we cannot simplify this at all. Okay. So this stays put. X squared and x are 2 different things, so we cannot combine them. Now for part E, we're going to talk in later sections about how we can convert back and forth, but time is something we're used to from a very young age. So if I take 2 minutes and add 5 seconds, I can't add the 2 and the 5 because it's not going to make any sense. It's not 7 minutes as a result. It's 2 minutes and 5 seconds. But what I can do is I can make these the same thing because they are representing similar types of things. So 2 minutes is exactly the same as 120 seconds. So we can convert that 2 minutes to make it so that they have the same unit. And now that I'm taking 120 seconds and adding 5 seconds, these are the same thing. So now it makes sense for me to add those two together to get 125 seconds. Okay. So again, we'll talk about conversions later on, but time is something you should be familiar with already. Okay. Now, there is a property that we're going to talk about, which is called commutative. So with addition, we say that addition is commutative, and what that means is the order doesn't matter. So if you think of adding 4 plus 3, that's 7. If you do 3 plus 4, it's the same thing. It doesn't matter which one you plug in first in your calculator. You get the same result. However, subtraction is not commutative. The order you put things in does make a difference. So just like you read a sentence, you're always going to read these expressions from left to right. So in this one, I want to take 4 and I want to subtract 3. If we do that, the result is 1. But if I do 3 minus 4, it's going to result in negative 1. Okay? So the order is important for subtraction. Okay. The last thing we're going to talk about in this section is what happens if we have fractions. Okay? So if you want to add or subtract fractions, you need to make sure the denominators are exactly the same. Okay? And all that means is when you have a fraction, you have one number divided by another. The number in the top is the numerator. The number in the bottom is the denominator. So if I want to add two fractions, they have to be talking about the same portion in that denominator. Because remember, 3 over 4 is technically a percentage, okay? So it's representing 3 out of 4 pieces of information. So what we can do to get something to be the same but with a different number in the denominator, we're going to take the top and bottom and multiply it by the same exact thing. So to give you an example, if I want to rewrite 1/6 with a 6 in the denominator, what I'm going to do is I'm going to take the top and bottom and multiply it by the same quantity. So in this case, because I want a 6 in the denominator, I'm going to take the bottom and I'm going to multiply by 3, which means I'm going to do exactly the same thing in the numerator. Okay? And so when you multiply, you're really multiplying across. So in the top, you'll have 1 plus 3, in the or 1 times 3, in the bottom 2 times 3. That results in 3 divided by 6. So 1/2 is exactly the same thing as 3 divided by 6. They represent the same exact percentage, okay? So when I'm going about and I'm trying to do addition or subtraction with fractions, the bottom piece is not going to change for any of these. But in order to be able to do the subtraction or addition, I want the same denominator. So in this first case, we have 3 over 7 plus 2 over 7. They have the same denominator. So what that means is I'm going to just add the numerators. So it's still going to be out of 7 pieces, and we just add the tops together. So 3 over 7 plus 2 over 7 results in 5 over 7. Okay? You have 3 pieces of a 7-slice pie. You're adding 2 into that pie. You have 5 pieces of that pie. Okay? If you want something in simplest form, what that means is you want to just reduce it as much as possible. So you're looking to see, can either of these numbers be divided by the same thing? And in this case, 5 and 7 are not divisible by anything other than themselves. So that's in its simplest form. Okay. For this next one, if we want to do 8 over 3 minus 2 over 3, again, same denominator, so I'm sitting good here. So all I'm going to do is I'm going to keep the denominator the same, and I'm going to take the first numerator and subtract the second, because again, the order matters. So I do 8 minus 2. So this results in 6 over 3. Okay. And in this case, 6 over 3, we can actually divide those two. 6 divided by 3 results in 2. Okay. So this is the answer in simplest form. Now for this last one, this is where things get a little bit more complicated because I have 1/3 and then I have 2/15. So currently they do not have the same denominator. So hopefully we don't have to rewrite both of these fractions, but sometimes you might. And in this case, I can get to a 15 in the denominator here. So what I'm going to do is I'm going to take the 3 and I'm going to multiply it by 5 because that'll give me 15 in the bottom, which means I'm going to do exactly the same thing in the numerator. So in the top, you'd have 5 times 1, which is 5, and then 5 times 3, which is 15. So 1/3 is exactly the same as 5 over 15. And then we're going to subtract 2 over 15. And now that they have the same denominator, we just go ahead and take the first numerator minus the other. So 5 minus 2 results in 3 out of 15, okay? And again, because the directions say put this in simplest form, I'm looking for 3 and 15. Can they both be divided by the same thing? And in this case, yes, they can. The top can be divided by 3, and so can the bottom. So the simplest form of this, 3 divided by 3 is 1, and then 15 divided by 3 is 5. So the simplest form for the result of this